para meron tayong record. Good morning, everyone, and we are now in our module number 8. This is also our 8th meeting. And as you can see, I am in the school. I am in the school. As you can see, around here are blank seats. No? There's no one here. Nakikita niyo siya. We are in the so-called bubble class. Yan. Sa rinig ko po, ano yun? Sa rinig ka po, ano to? I don't understand. Ka po dyan. Nobody can hear me because nobody is teaching. But if there is someone siguro on the other side, they might hear me talking. But I'm now speaking very, very softly. So I think, Miss Borlongan, it's okay, Miss Borlongan. You have to hold on with the class. Even if you cut, make sure na you reconnect na lang siguro. And the class will be recorded naman as well. So it's okay. All right. So moving on, let's now proceed with the intended learning outcomes. And as you can see here, our intended learning outcomes are the following. So we'll be at the end of this module, you should be able to explain how the network layer uses the IP protocols for reliable communications. Number two, explain the role of the major header fields in the IPv4 packet and the IPv6 packet. Explain how network devices use routing tables. So we'll be covering the routing tables today. If you heard about the MAC table last week, now you have the routing table. Okay, and then explain the function of fields in the routing table of a router. Okay? Tanong ko lang sa inyo kung okay lang yung naiintindihan niyo ako. Hindi lang basta audible, but do you understand kasi naka-face mask ako. Baka ako nahirapan kayo sa akin. Naintindihan naman. Okay, thank you. So moving on, let's now proceed with the first part, which is the how do we understand about the layer 3. Okay, so we'll be talking about the network layer characteristics. From the last week's topic, we discussed about the data link layer, right? And if you remember, we covered about the physical addresses, no? The source and the destination physical addresses. We also talk about the protocol data units in the data link layer, which is the frames. Okay? But today, we're going to talk about network layer. What are the characteristics of the next layer? Now, coming from the physical layer, and then we go with the next layer, which is the data link layer. And then after that, we proceed with now, we have the network layer. What are the characteristics of the network layer? So this is the different functions that the network layer does. Okay, you can see here that the network layer is the layer that provides services for end-to-end exchange of data. So it uses the IP version 4 and the IP version 6 principal layer of the network layer communication protocol. So the long protocol to that are existing in the layer 3. We have the IP version 4 and the IP version 6. And there are 4 basic operations, as you can see here. There are 4 basic operations in the network layer. We have the addressing of end devices, and then the encapsulation is also present here, as well as the encapsulation. But more importantly, the network layer is responsible for the routing. So we'll talk about that later. Okay. So let's talk about the encapsulation first. Last week, when we studied about the data link layer, we understood that the encapsulation and the encapsulation happens in layer 2, right? And as the data travels to from physical layer, going to the data link layer, the bits becomes frames. Why? Because the encapsulation process covers the bits into some portions, some portions of it, and then there are headers and trailers that are given, on the data link layer. Kaya tinawag siyang frame, data header and trailer for the frames. Okay? But in network layer, yung encapsulation natin dito, we're no longer concerned about the frame. But we're talking about how it encapsulates the segment layer, no? Kasi pag napunta sa kanya dito in this particular layer, when the segment layer reaches the network layer, no? Coming from the transport layer, what it does is it encapsulates the packet. No? So yung tawag natin sa protocol data unit in this layer is no longer a segment or no longer a frame kasi yun yung pwedeng panggalingan ng network layer from the transport layer or from the data link layer. Okay? Pwedeng galing sa segment or pwedeng galing sa as a frame. No? But here, ang tawag na sa kanya is no longer called to be a segment or a frame, but ang tawag na sa kanya ay packet. Okay? Remember that in network layer or layer number 3, ang tawag na sa kanya ay packet. An IP packet will be examined by all of the 3 devices as it travel across the network. No? So, ayan, yun ang nangyayari. So, diyan yung ginagawa natin sa encapsulation. As you can see from the illustration here, the contents or the components of the IP packet is consisting of the IP header and the data. So coming from the above example here, no, kung dati siyang segment and the data coming from the transport layer PDU, so ma-encapsulate siya and then ma-encapsulate siya rito sa layer 3 and it becomes a packet. Okay? How does it become a packet? Because the IP header is attached on the data. So that it becomes an IP packet. Okay? The characteristics of IP or Internet Protocol, it's because you need to understand that in the network layer, the protocol that is commonly known or commonly used is the IP or the Internet Protocol. IP is meant to have low overhead and may be described as number 1, connectionless, number 2, best effort, and number 3, media independent. So let's see one by one the meaning of the terms connectionless, best effort, and what's the other one? Media independent. So when you say connectionless, the IP does not establish a connection. Kaya nga ang tawag sa kanya connectionless. So that means hindi kailangang kumonect ni sender kay receiver para mag-send siya ng information. Okay? Kaya nga siya connectionless. So ibig sabihin, we don't care about synchronization here. No? You don't need to check na kung ikaw yung magsasend ng data, ikaw yung sender, tapos sa receiver, you don't need to check if the receiver is online or offline. Okay? So that is what we call connectionless. No? The destination, ang duty niya, itatanggapin niya lang yung, or i-receive niya yung packet kapag dumating. No? But there are no notifications. No? In the Internet Protocol, there is no notification if the message is received or not, no? Yan yung ating meron sa connectionless, no? So as you can see from the illustration here, 'di ba yung dating communication natin ganito? When you send your letter, you put it in the mailbox and then the mail is sent to your home, no? Or to the destination. And when the letter is received, wala namang notification na ipinapadala, oh, I receive your letter. Diba? Wala namang ganung notification. That is what we call connectionless. What about best effort? Best effort naman in the IP or the Internet Protocol, it will not guarantee the delivery of the packet. So that means hindi siya concerned kung ma-deliver yung packet o hindi. Kaya hindi siya concerned doon. Right? The IP has reduced overhead since there is no mechanism to resend data that is not received. So, ibig sabihin, kapag pala yung isang packet hindi nakarating, there is no need to resend it. Okay? And there is no expected acknowledgement if it does receive or not. Okay? And does not know if the other device is operational or if it received the packet, no, as I mentioned a while ago. Okay? Basta ang tinitiyak dito, the packets are routed through this connection. For example, in this case, the packets are routed through the network quickly, and some packets may be lost en route, no? So ibig sabihin along the way pwedeng may mga packets na nalolos, no? But it's not concerned, no? Yung IP protocol is not concerned on determining whether there are whether the packets are delivered or not. Okay? What about media independent? IP is unreliable. So that means it cannot manage or fix undelivered or corrupt packages or packets. So it basically media independent, no? So that means hindi niya concern yung kung anong type ng media yung dinadaanan niya, kung wireless, kung wired or copper ba yung dinadaanan niya. So nakarely siya, hindi siya nagre-rely doon. It doesn't matter. It's because kung merong mga undelivered or corrupt packets, as you can see here, it cannot manage it. No? Hindi trabaho ni layer 3 o ni internet protocol yung ano. Hindi rin trabaho ni IP na magre-transmit ng error. Okay? So nakikita natin dito, there are seems like unreliability, but basically layer 3 is like that. No? The internet protocol is like that. Okay? Okay, as you can see here, this is another example of the continuation of the media independent explanation where the network layer will establish in this case, the maximum transmission unit or the MTU, okay, as it received the form sent by the data link layer. Okay. And as you can see here, when layer 3 splits the IPv4 packets into smaller units, there will be some fragmentation, and the fragmentation will cause latency or delay of the packets. So not so much of that. Let's proceed with the explanation of the IPv4 packet. So what is the composition of the Internet Protocol version 4 packet? So remember that there are two protocols in layer 3, version 4 and version 5 of the Internet Protocol. But inside the packet header of the IPv4, we can see, before we get to the details of the packet header, let's see the purpose of the header. Okay? So, ito lang yung mga dapat natin tandaan sa header ng packet header natin, that the network header ensures that the packet is sent in the correct direction or the destination. Kasi may address ka, di ba? So, it ensure na tama yung padadalhan. Hindi siya laging nagkakamali. Okay? It contains information for network layer processing in various fields. Okay, number 2. And then last, the information in the header is used by all layer 3 devices that handle the packet. Yun yung ginagawa niya. Okay. Next, you can see here the packet header fields. So makikita natin dito, these are the composition of the packet header. No? So aside from the data, what else do we see from here? We have a 20 bytes information. Okay, binary to ha. Binary siya. Ibig sabihin ones and zeros lang to. But it contains several fields of information, as you can see here. Okay. Each of the information here, like for example here, you can see that the most prominent important fields here are the source IP address and the destination IP address. Last week, MAC address yung diniscuss natin. But this time, logical address ang pinag-uusapan natin. The source IP and the destination IP. Yung iba dito na mga fields, kagaya ng TTL, protocol, identification, flag, total length, header, checksum, these are all important elements then. But these are basically for checking the packets lang. Okay? Checking the authenticity of the packets that is being sent. No, ayan, merong mga description dito. Yung mga version, halimbawa, A packet header has a version, no? Of course, nakalagay dito kung version 4 yan o version 6. Second, nakalagay din dito kung differentiated services o POS o kung anong type ng service ang ginagamit, no? And then yung header checksum, it detects if there is a corruption in the header. Kung wala, naka-zero lang siya yung checksum natin. Time to leave o TTL, yung layer 3 hop count, no? When it becomes 0, the router will discard the packet. So basically, para masabi nating tama yung TTL natin, dapat it is not equal to 0. Pag naging 0, the packet will be discarded. Of course, we have the protocol, no? Ano bang protocol yung nagamit natin? Is it ICMP, TCP ba yan, UDP? Yan. And then, of course, the most important is the 32-bit source address and the 32-bit destination address. Or we call it, in some terms, we call it the IP address. There is a video here, no? At a sample Internet Protocol version for headers in Wireshark. So please watch this in your NetAcad account, no? Because this will explain how the Ethernet packets in Wireshark is being seen. No? So check na natin itong video na to. Mukhang maganda tong video na to na i-share natin. NetAcad. Okay, wait lang. Yung mga late natin, paki-chat na lang kung ano oras kayo dumating para ma-check ko yung attendance niyo later. Open ko lang yung ating NetAcad account para ma-share ko sa inyo yung video para nakasynchronous yung ating information. Okay, let me launch the course. I believe there is a schedule today, no, nung exam ninyo, assessment. Don't worry, no. I will extend the exam later. So, i-remind nyo ako na extend ko yung exam ninyo later. Okay? But let's listen first or let's watch the video about the IPv4 header. Medyo yan. Okay, mabilis naman ang internet dito, so okay siya. So let's just see kung anong module natin. We are now in module number 8, network layer. And I think there is a video here in Wireshark. Yan, this one. No? So I'm gonna share this video. Allow me to share this. And let's watch it. Can you give a feedback kung narinig nyo yung video? I'm gonna play the video.
I have a screenshot from a Wireshark packet capture, and you can see that the second packet that's been captured has been highlighted. And then in the packet details window, the network layer information has been expanded to show us all of the things happening at the network layer. So let's see what's happening in this particular packet that we're examining. We can see that, first of all, the network layer protocol or internet layer protocol that we are dealing with was Internet Protocol version 4, IPv4. We can also see that the source IP address was 192.168.1.109. You can see it also highlighted up here in the packet list window area, and that the destination IP address was 192.168.1.1, and we can also see that up here. We can see that at the higher layer, this is a TCP protocol packet, but if we limit ourselves to just the IPv4 fields or the IPv4 information, we can see the different types of control information that's contained in every IPv4 packet. For instance, the version number, which is 4, identifying this as an IPv4 as opposed to IPv6 packet. The header length, or the length of the header, this is the minimum size of an IPv4 header. The differentiated services field, which is used for packet prioritization and is useful for applications like voice over IP. The total length of the packet. The identification number, which is used for fragmentation. The flags, you can see that the DF bit has been set, which stands for don't fragment. This packet is not large enough or is not identified for fragmentation. Fragment offset. The TTL, or time to live, which is set to 128. Every time a packet is routed from one hop to the next, the TTL number is reduced. When the TTL number reaches 0, the packet is dropped, ensuring that packets don't circulate on the internet forever on an endless loop. The TTL value is also used in ICMP trace routes and pings. The protocol field lets us know the type of information to expect in the data portion of the packet. A 6 identifies the data portion of this packet as being a TCP packet. The header checksum field, which allows routers to check to see if there are any errors or inconsistency in the IP header. If there is, the packet will be dropped. And then lastly, the source and destination IP addresses, which are the most important part of the IPv4 packet. Let's take a look at 2 more screenshots of Wireshark packet captures, and we'll see some similarities and differences. The next screenshot shows us that now we're looking at the 8th packet captured. The packet's source IP address is also 192.168.1.109, and the destination IP address is 192.168.1.1, except this packet is an HTTP GET request. So this is a request to a web server located at 192.168.1.1. You can see that the network layer or internet layer information has been expanded, that it's also the IP version 4 protocol, and that we have similar information in the different fields. Notice under the total length field that this packet is 411 bytes compared to the previous packet, which was only 52 bytes. You can tell that this packet has a lot more information, or is a much larger packet than the previous one. If we look below the Internet Protocol version 4 information, we can see the TCP information, and then below that there's Hypertext Transfer Protocol, or HTTP protocol information in this packet as well. I'll move forward to the next packet, and you can see that this packet is the 16th packet captured right up here. It's also from host 192.168.1.109 to host 192.168.1.1, except this is the ICMP protocol. You can see from the information in the packet list window that this is an echo or ping request. If we look in the Internet Protocol version 4 information in the details area, we can see some minor differences. The version is still 4, the header length is still 20 bytes, but we can see that the flags are slightly different, and that the protocol field is now set to 1, indicating that the data portion of this packet is an ICMP protocol message. Notice that in the details window at the bottom here is an expanded area to look at the header information specific to ICMP.
All right, so you have seen the explanation of the IPv4 headers, no, that was captured in Wireshark. So yung pinag-aralan natin dito ng mga headers, no, yung mga packet header fields like version, TTL protocol, source IPv4, tsaka destination IPv4 addresses. In action, makikita natin yan if you use the Wireshark, no, na application. Wireshark application is a monitoring tool. It's an analytical tool that we can use to capture packets, no. So pag nagka-capture tayo ng packets, especially if we are browsing the internet or any other thing that we are doing, no, so we can use it to capture packets and examine it later, no. You can see na by using Wireshark, we can examine the IPv4 packets, no, as we have seen from the video. Now, let's try to understand naman yung version 6. Are they the same with IP version 4? Most probably hindi, no? It's because of the depletion of the IPv4, kaya meron tayo ngayong IPv6, no? And then, the limitations extended to the increase of the network complexity na kapag nagiging complex na yung network, hindi na applicable yung mga IP version 4 because it's limitation. Another limitation is the lack of end-to-end connectivity of IP version 4. No? And as you can see here, and it's because of these three limitation kaya bumangon yung development ng IP version 6. No? Ang nag-facilitate niyan is the Internet Engineering Task Force or the IETF. They overcome the limitation of IP version 4 by improving the protocol, which is the version 6. No? Yan. In-improve nila. But instead of using 32 bits, meron na tayo ngayong 128 bits, which is a lot, di ba? Kung i-compare mo yan, at i-compare mo yan sa 32 bits, 128 bits is around 4 times, di ba? 4 times siya. It has an improved packet handling and it eliminates the need for network address translation. So basically, so makikita nyo rito sa ating image. So ayan yung comparison between the spacing ng IP version 6. So around this many, no, yung number of zeros na to ng version 6 compared sa billion lang ng version 4. Okay? But in version 6, you can see na mas malaki yung nakalagay dito, there are 4 billion IPv4 addresses, but there are 340 undecillion IP version 6 addresses. So much probably, hindi mo kayang ubusin yan. Okay? Hindi natin kayang ubusin. Now, ito naman yung difference ng kanilang fields. No? Sa version 6, mas simplified, pero but not smaller. Okay? Medyo malaki pa rin yung yung kanyang byte size. Kasi di ba 20 bytes lang yung sa version 4. Ito, 40 bytes naman. Okay? But some of the fields here are simplified. And as you can see here, ito na lang yung mga natira sa kanila. Kasi sinimplified siya. Ito yung comparison, yung dating IP address ng version 4, ngayon ay 128-bit na. And then, of course, may hop limit pa rin. Yung hop limit, ito yung dating TTL. Tapos may next header dito. May payload length, may flow label, traffic class, tsaka version. So, yan yung mga pagkakaiba ng packet header natin sa... And then, it also contain extension headers. No? Para saan ba yung extension headers na yan? Ayan yung mga pinoprovide niya. No? Optional lang siya na information at nakalagay siya in between the header and the payload. Okay? It can be used for fragmentation, security, mobility support, etc. But unlike version 4, routers do not fragment version 6 packets. Yan. Let's see the video. No? Puntahan natin yung video ng IP version 6 na packet para mas maintindihan natin. Okay? So let's see the video here. I'm gonna play the video para makita natin kung paano kina-capture ng Wireshark ang version 6 natin. So let's see.
This screenshot shows a packet capture using Wireshark and the network layer information from an IPv6 conversation. Let's take a look at it. In this screenshot, we can see that the highlighted packet is packet number 46, and that the source address up here in the packet list window shows that it is a global unicast IPv6 address. You can see this starting with the 2001:6F8. The destination address is also a global unicast address, 2001:6F8-900, and so on. And if we look over in the protocol field, we see that at the upper layers, this is a TCP packet, and that it's an attempt to establish an initial communication with an HTTP web server. If we look down in the network layer information area, you can see that the IPv6 information has been expanded. Let's take a look at some of the protocol field information for Internet Protocol version 6. First of all, you can see that the amount of information in the IPv6 header is much smaller than in the IPv4 header. Now, there are some interesting features. For one, you can see that the version field is the same. In this case, it says 6, identifying this packet as IPv6. We can also see the binary 6 here. The next field is the traffic class field. The traffic class field serves the same function as the differentiated services field in an IPv4 packet. It handles traffic prioritization and congestion. The next section you can see is the flow label. The flow label field is a new field for the IPv6 protocol. Its purpose is to maintain the same packet flows through routers and switches so as to help real-time applications that need packets to arrive in the same order. You can see the next field is the payload length field. This is the same as the total length field in the IPv4 header. This field tells us the total size of the packet, in this case 40 bytes. The next header field serves the same purpose as the protocol field for IPv4. You can see that it's identifying that the upper layer data portion of this packet is a 6 or TCP. The hop limit serves the same function as the TTL field in an IPv4 packet. You can see that the hop limit currently is set to 64 hops. Once this decrements to 0, the packet will be dropped. Next, we have the source IPv6 address, the destination IPv6 address, and then at the upper layer, we can see that this is a TCP packet with TCP header information. Let's take a look at the next screenshot. In the next screenshot, you can see that we've now highlighted packet number 49, and now we have a connection with this web server. This packet is now a GET request to the web server. If we look down in the expanded Internet Protocol version 6 packet details window, we can see that the payload length is a lot larger. We can see below the IPv6 information, the TCP information, and that now there is HTTP protocol information as well within our GET request. This is our GET request to get a web page. If I go to the next screenshot, the last screenshot shows an ICMP version 6 neighbor solicitation message. If we look up in the window at the highlighted packet here in packet number 1, we'll see that the source address this time is not a global unicast IPv6 address, but a link local address. We can tell that from the FE80 here. We can also see that this link local address used EUI64 to resolve the interface identification portion of the address. We can tell that by the FFFE within the address. The destination address is an FF02 IPv6 address, indicating that this is a multicast packet. If we look over at the protocol, we see that it's ICMP version 6, and then information about the packet tells us that this is a neighbor solicitation message for the same device that we were contacting in the earlier screenshots. The function of this packet essentially is similar to an ARP request in IPv4. We need to discover the link local address of this device, so we send out an ICMP version 6 neighbor solicitation message, multicasted, and we're hoping to get back a link local address from this neighbor. If we look down in the expanded details window, we can see the version is 6, traffic class flow label, payload length, which is the entire length of the packet, the next header field, which is like the protocol field in IPv4, indicating a 58 that this is an ICMP version 6 message in the data portion of the packet. The hop limit, 255 hops. This is similar to the TTL field. And then the source, link local address, and the destination multicast IPv6 address. At the bottom, below the IPv6 information, we can see that there's an expandable area specific to the Internet Control Message Protocol version 6.
All right, ayan. So similarly, as shown in the previous video about the IPv4, you can also check the different header fields. I mean, the different fields of the IPv6 packet in Wireshark. No, it's because kapag nag-capture tayo ng packets, and if the packets are captured like an IP version 6 packets that are captured, so makikita natin basically yung mga information. No? Kaya dapat marunong tayong mag-capture ng packets sa Wireshark, and then marunong din tayo magbasa kung ano yung mga information that we can analyze from the Wireshark. How a host routes. Ayan, let's see, no? Paano tayo nagra-route ng traffic using the layer number 3. Right? So you can see here that when packets are sent, no, from the source to a destination, who's gonna decide for the decision of the packet, no, kung saan siya dadaan. Remember, packets are always created at the source, and each host devices creates their own routing table. And as you can see here, now for example, in this case, the PC1 is the origin of the packet. No? So basically, a host can send packets to the following uh, conditions. For example, a host can send a packet to itself. A host can send to a local host, which is PC2, and it can also send to a remote host, which is the remote host as shown here. So pwede nating i-send ang packet natin to anyone, no? Which is hanggang ma-reach yung packet, it can be sent, no, all throughout the network, as you can see here. So ang decision kung paano fino-forward yung mga packets is based on the host, di ba? Siyempre siya ay naglalagay kung saan yung destination, di ba? So halimbawa, ang destination ng packet niya is to another local host. So kay PC2 niya ilalagay. On the other hand, if it is to the remote host, dito niya naman ilalagay. Okay? Host forwarding decision. However, there are two ways to determine, no, if the forwarding decision should be decided. No? For example, here, the IP version 4, the source uses its own IP address and subnet mask along with the destination IP address. So yun yung determination kung paano niya i-forward yung mga packets. But in IPv6, ang ginagawa niya, the source computer, okay, it uses the network address and the prefix advertised by the local router. So nakadepende siya sa router. Okay, not unlike sa IP version 4 na nakadepende siya doon sa routing table na nasa kanya mismo, sa host mismo. Pero sa version 6, nakadepende sila doon sa local router. The local traffic is dumped out the host interface to be handled by the intermediary devices, and the remote traffic is forwarded directly to the default gateway of the LAN. Now, what about the default gateway? Another thing that you need to remember in layer 3 is that in a router or layer 3 switch, no, it always has a default gateway. And what is a default gateway? The default gateway is your access. Now, if you are locally connected, nasa bahay ka, yung router mo will be the gateway to the outside world, which is the www, di ba? So, anong ibig sabihin ng gateway? Gateway is the door, no? Ito yung pintuan para makapasok sa iyo ang labas at ikaw naman ay para makalabas. Okay? But a default gateway or DGW, as an abbreviation, there are characteristics or features that you need to remember. Number one, it has an IP address. Usually, kung router ka sa, if you are using a private address, di ba? Ang gamit mo ay 192.168, yan, .1.1. Usually ganun, no? Sa Converge, 192.168.100.1. Okay? in some networks 168 192.168 dot 10, no? Dot 1. Kaya yung iba naman 10.10.10.1. Okay? Iba-iba sila, no? Magkakaiba sila ng configuration. But basically, ang gamit ng na address ni default gateway is always a private address. Okay? And this address can accept data from the local area network and capable siya na mag-forward ng traffic papalabas ng local network. No? It can also route to other networks. So, yun ang kakayahan ng default gateway natin. Pwede siyang mag-route ng traffic. Now, if a device has no default gateway, or tawag natin doon ay bad default gateway, the traffic will not be able to leave the LAN. So remember, merong mga cases na bakit wala kang internet. Chine-check mo, nakakonect ka naman sa internet, pero bakit wala kang internet? Access denied or may problema sa server. Chine-check mo, wala. Yung pala ang problema, you have a bad gateway. So ang lesson doon, you need to check if you are connected to your router and if you are using the address or the default gateway of the router. Otherwise, kung hindi, your traffic will not leave and no traffic will come in as well, no, to your local area network. Kasi ang default gateway is the gateway of all the incoming and outgoing packets. Right? Remember that. Paano po nagkakaroon ng bad gateway? Halimbawa, sometimes nangyayari yan kapag yung IP address ay configured kung na-configure siya ng manual. Okay? So, ibig sabihin, kung manual siya na-configure, di nagse-set ka ng IP address doon, nagkataon na yung router na ginagamit ay hindi na yun ang ginagamit na default gateway. So, sa mga PC mo, ang nakalagay, yun yung address ng default gateway, pero iba na pala yung default gateway address. So, nagbago na. So, doon nagkakaroon ng bad gateway. Okay? Pero usually nangyayari lang naman 'yun pagka manual configuration. Pero kung dynamic yung configuration ng network mo, no, using the dynamic host configuration protocol or the DHCP, 'di ba? So ang nangyayari, automatic na binibigyan ka ng default gateway talaga at saka ng DNS server address. Okay? But in any case, bihira naman mangyari ang bad gateway niya. Okay? Ito yung host routing table na binabanggit natin kanina. Sabi natin, one of the capabilities of the host, no, in a network is to route traffic. Paano niya na-route yun? It's because yung mga PC natin may sarili siyang tawag dito, may sarili siyang routing tables, no? So if you are a Windows user, you can check your routing table now by typing sa terminal nyo, mag-type kayo ng netstat space -r, no? I-display niya ron yung routing table nyo. So tatry ko dito sa aking PC. Punta ako sa terminal. Try nyo rin sa inyo, no, para makita nyo yung routing table nyo. Tingnan nyo kung merong, yan. So nakikita nyo rito, i-share ko sa inyo tong aking window. Ang gamit ko ay MacBook. So makikita nyo rito na ito yung tinype ko, netstat -r. I think nakikita nyo naman siya, di ba? Nasa school ako kasi, nasa TIP ako. So ito yung nakikita nyo na meron akong default gateway dito. Ang configuration ng default gateway dito sa school ay 172.30.0.5. Ayan. Tapos meron tayo rito ito, version 6 to, no, na using my ito kasing EN0 na to, ito yung aking interface na gamit, no. Interface 0. And then ito yung destination ng lahat, no. So lahat ng connection, meron ako niyan, nakikita nyo rito, no? Ito naman yung version 4 yung una. Pero dito sa baba, yung version 6 na to. So, nakikita nyo ang routing table na naka-install dito sa aking MacBook. Ayan, meron tayong version 4, meron din tayong version 6. Mas maraming information yung version 4 kaysa sa version 6. At yung version 4, ito lang yung nakikita natin. Ilan lang siya, no? Ayan. Pero makikita nyo until now, gumagana pa rin yung pag-trace ng ng mga routing table natin. Okay? So let's leave that and continue with our discussion. Now, let's introduce ourselves to routing. So, earlier, sabi natin, in layer number 3, ay meron tayong mga device na kung tawagin ay mga routers at saka yung mga layer 2 switches, no? And routers specifically, ang function ng router is to route traffic talaga, no? But we need to understand what happens when the router receives the frame from the host device, no? As you can see here, kung lalakihan natin tong mga words na nandito sa baba, no? When the packet arrives on the gigabit Ethernet na 000 interface, no? Ito 'yon. Of router number 1. Ito yung router number 1, galing ng PC, nag-send ka ng message. So kapag daw yung packet dumating dito sa 00 interface na to, R1 will de-encapsulate the layer 2 Ethernet header, okay? And trailer. And then router 1 examines the destination IPv4 address. So nakikita nyo rito, meron siyang destination IPv4 and meron din siyang IPv4 address of the packet and searches for the best match in the IPv4 routing table, and the route entry indicates that this packet is to be forwarded to router 2. And then router 1 now will try to encapsulate the packet into a new Ethernet header and trailer and forwards the packet to the next hop, router R2. Ayan. Nakikita nyo sa illustration na binabase dito sa routing table, no? So galing ng kung ang message ay galing doon sa route na to, since meron siyang so nakikita ni router yung next hop natin or exit interface kung saan ipapadala niya, depende doon sa nakalagay na depende kung ano yung nakalagay na details doon sa packet natin. Okay? Okay, so sa routing table natin, kung ang mga host ay merong routing table, as I shown you, pag gumamit tayo ng netstat -r attribute, makakakita tayo ng mga routing tables doon. Pero we have the routing table, and inside your routing table, inside your router there is also routing table. But this one, it's different format, no? And you can also see that. You can only see that if you have an access to a router. Okay? And the three types of router that you can see, three types of route, no? Yung kumbaga sa dadaanan, kumbaga sa kalsada, ayan, sa kalsada ng dinadaanan ng sasakyan. Sa router, meron ding tatlong route, no, na nakalagay sa routing table. It's either directly connected, remote, at saka default. Unahin natin yung directly connected. From the illustration, makikita nyo rito na itong router 1 na to, no? Ang mga directly connected na network sa kanya, ito ang tinutukoy ko sa R1, in terms of R1, ang directly connected sa kanya ay ang network na to at ang network na to. Yung dalawang yan. Yan ang sinasabing directly connected. That means these routes are automatically added to this R1 router, but the interface should be active, no, and has an address. As you can see, active naman siya, no, may network address siya. So lahat yan mare-register dito sa routing table ni R1 as directly connected networks. The question is, ano naman ang remote? Coming from the perspective of R1 pa rin, these are the routes that the router does not have a direct connection and may be learned. No? It can be learned manually or dynamically. Pag manually, maglalagay ka ng static route. Pag dynamically naman, gagamitan mo ng routing protocol. Okay? So itong network na to na malayo na sa kanya, no? Kasi dadaan na sa panibagong router dito. So ibang network na to, 'di ba? So ang tawag diyan with respect to R1, remote network 'yan. No, paano malalaman ni router 1 na merong network dito na ang pangalan ay remote network? Paano niya malalaman na may address diyan na 10.1.2.0 network? Malalaman niya yan kung sinet mo yung static route or pwede niya malaman yan through dynamic routing protocol. Okay? Another route is the default route. Ano naman ang default route? This forwards all the traffic to specific direction when there is not a match in the routing table. For example, itong si router 1. Nag-send ng traffic itong PC1 na to, no? Nag-send ng packet. Since meron tayong default route, kapag hindi niya nakita yung address, kung halimbawa ang default route niya ay nasa network na to, no? Halimbawa may connected pa ditong isang network at dito naka-design yung default route, no? Kapag hindi niya nakita yung address, no, kumbaga sa programming, yung default parameter na tinatawag, 'di ba? If you remember the default parameter, yun yung pine-perform. No? Ganun din sa networking. Kapag hindi makita ni router yung address ng destination, ipapadala niya sa default route. Doon niya pino-forward lahat yung traffic, no? Yun yung ibig sabihin ng route na yun. So tatlong klase yan, remember, the directly connected, the remote, and the default route. Sa remote, there are two ways on how you can access the remote by dynamically assigning it using routing protocol, and the other one is by manually designing it. Okay? Ayan. Ito naman yung example ng static routing, no? Sabi natin kanina dito, no? Using manual, ma-detect natin ang remote, no? Kaya lang kailangan natin ng static route. Paano natin ginagawa ang static route? Ito, pini-configure yan manually. Halimbawa, itong router na to. Okay? Nakalagay dito IP route. Ito yung command no, para ma-configure mo yung static route, no. IP route, tapos i-add mo tong network address na to. Okay? I-add mo yung IP address ng remote network address at i-add mo rin yung address ng next hop router. So kung ano yung address ng next hop router, kasunod yun. In this case, ito yung network address 10.1.1.0 with a mask of 255.255.255.0, and along with that, after the subnet mask, ilalagay mo yung IP address noong next hop router. So ito yon, yung gateway niya rito. Pinaka-gateway niya rito. Then R1, katulad nito, dito naman, ang kagandahan sa static route, no, kapag ka nagkaroon ng problema, nagkakaroon ng redundancy. No? Lalo na kung very small lang yung network, no? Using a static route is very efficient. Sa dynamic routing naman, ito yung paggamit ng routing protocol, no? So dinidiscover niya yung remote networks, no? Bali ang gumagawa niyan automatic kasi yan. Depende sa protocol. Halimbawa, the protocol maintains using a routing protocol, i-maintain niya na up-to-date yung information by refreshing the table. No? So ang ginagawa niya, nagbo-broadcast siya ng traffic, no, para ma-learn niya yung mga remotely connected na networks. And then hinahanap niya yung mga best path, no, when there is a change in the topology. No? So I have a video here No, this is the video to explain the information in the IPv4 routing table. Let's try to understand this, how it happens. No, paano ba pino-forward na paano nira-route yung ano natin. Tingnan natin dito sa video na to how it is explained in the router's IPv4 router routing table. Let's see ha, panoorin natin. Very short lang naman to. Don't worry.
A router uses information in its routing table to forward packets. A routing table displays entries listing all the networks that a router is aware of and the best path to reach them. It is very important to be able to read and understand the entries in a routing table. In this demonstration, we'll take a look at a router's IPv4 routing table in detail. But first, let's examine the network topology. It actually consists of 5 separate networks or subnets. There are 4 LANs, 2 connected to each router, and 1 WAN connection between the 2 routers. If we look at R1, it has 3 directly connected networks. Network 192.168.1.0 connected to interface G0/0/0, network 192.168.2.0 connected to interface G0/0/1, and network 209.165.200.224 connected to interface S0/1/0. R2's LANs are not directly connected to R1, therefore they are considered to be remote networks as far as R1 is concerned. In order to forward data to remote networks, a router needs to learn about them first through the use of static or dynamic routing. In this example, R1 has learned about them through the dynamic routing protocol OSPF, which has been configured on both routers. To view the IPv4 routing table, I'll click on router R1, and from the CLI tab, I'll press enter to connect to the command line. From here, I'll type enable and press enter to enter privilege exec mode, and from here, I'll issue the show IP route command to view the routing table. If I press the space bar, I will see the full output. At the top of the output are letter codes that indicate how each network, aka route, was learned. This is referred to as the route source. Underneath that, we can see the routing table entries. These represent all the networks that R1 knows about and the best way to reach them. Let's further examine some individual entries. First, let's look at the entry for network 192.168.1.0. The letter C in front of the entry is the route source and indicates that the source of this route is a directly connected network. And you can also see that in the entry here. Gigabit Ethernet 0/0/0 is the interface to which that network is connected. Now let's look at the entry for network 10.1.1.0. This entry has a route source of O, which indicates that it was learned via OSPF routing. After the network address, you can see 2 numbers in brackets that are used by the router to help determine the best path to the network. The first number is the administrative distance, which indicates the trustworthiness or preference rating of one route over another. Next is the metric, another value used by the router to help determine the best path. The metric may be calculated using hop count, bandwidth, or some other factor. This network is reachable via this next hop address, which represents an interface on router R2. This is a timestamp that tells us how long ago this router last received an update on this route. And serial 0/1/0 is the exit interface on R1 through which to send the packets. For the purposes of this demonstration, you can ignore any entries that do not list a route source at the beginning. These are basically headings. Also note that for each directly connected network, you have an entry below it with a route source of L. L refers to a local route, and basically this is the IP address of the interface to which that network is connected. This routing table shows that R1 is aware of all 5 networks present in the topology. It has 3 directly connected networks, it has 2 networks that are remote and were learned through OSPF routing. And lastly, if you look at the last entry in the table, you will see a statically configured default route. This manually configured route can be used to forward any packets that don't have a specific entry in the routing table. The purpose of a default static route is so that the router will not drop any packets. These are just some of the basics of an IPv4 routing table.
Ayan. Okay, so we have watched the example of a routing table kasi wala naman tayong router dito, no? But I can show it using, if you can use it, you can examine the routing table. Just create a small network in Packet Tracer and then connect a local area network. You also may have to connect another remote layer or remote network para makita nyo when you do the show IP route command, yung routing table. Routing table can be seen, and you can see what are the networks, especially if your network has addresses. No, those are very important things that you need to consider. Okay, yan. So this is an example of what we gathered from the video. So these are the abbreviations of the different routes or route sources using the show IP route command. No, ito meron tayong L, which means direct local interface siya, directly connected. On the other hand, C naman ay directly connected network. So anong kaibahan ng L at saka C? Yung isa network, yung isa naman local interface. Okay? Yung S naman is a static route, usually administrator yung nag-configure. And then yung protocol natin, we have 2 protocols dito na O at saka D. O is OSPF and the other one is EIGRP. And makikita rin natin na ang mga directly connected dito ay yung CNL, ang remote natin ay OND, and default route natin which is static is S. Ayan. I think that's the end of the it's a little bit of a very short discussion explaining about the IP layer 3, no? So we talk about the characteristics of the layer 3, which is connectionless, best effort, and media independent. We also learned that in layer 3, it doesn't guarantee the packet delivery. And we talk about IPv4 and IPv6 headers, no? And then on the last part, we talk about the routing process as well as the routing table that are used in our network. So if you have some questions related to the discussed topic, please send your topic using our public chat. May question po ba tayo? Question po. Now, the assigned assessment dito sa inyong schedule, meron kayong may activated dito. Na-access nyo na ba to? This is from 10:30 to 1:30 ngayon, no? Can you access it now? Sinong hindi maka-access? Supposedly dapat, yes, yung NetAcad exam. Dapat na-access nyo yung NetAcad exam ngayon. Paki-check nyo lang kung na-access nyo siya. Kasi mamaya, baka mamaya meron na naman magme-message sa akin habang nagpapahinga ako, mang-iistorbo sa pagpapahinga ko. Sasabihin, Sir, sorry, hindi ako nakapag-take ng exam doon sa oras na binigay mo. Accessible siya, no? Ang gagawin ko, maglalagay pa ako ng additional schedule. No? Mag-aano ako dito ng additional schedule from 1:30 hanggang mamayang gabi. Pwede nyo i-take yung exam. Kasi ginamit ko yung oras nyo ngayon for the lecture. No? Dapat kasi ngayon nyo i-take yan. No? Pero dahil ginamit ko, papalitan ko yung oras. At mas marami pa akong ibibigay sa inyong oras. So, Ethernet Concepts exam yun, no? Ethernet Concepts exam. So, I'm gonna create an advanced activation. And this is gonna be from, dapat 1:30 ng hapon to, mag-i-start. Kasi doon mag-e-end yung isa. And it will end around 11:30 ng gabi. 11:30 ng gabi. Sa NetAcad po to ha. Baka mamaya may mga nagtatanong na naman. Kasi hindi kayo nakikinig kaya kapag nag-explain ako, hindi nyo naiintindihan kasi hindi kayo nakafocus. Okay, meron daw conflicting activations dito. So, dapat ang gawin ko ay, I'm gonna create another activation. Ulitin ko lang. Siguro gagawin kong from 2 o'clock in the afternoon. 2 o'clock to ha. Guys, 2 o'clock ha. 2 p.m. until 11:30 p.m. Mamayang gabi. Ayan. So let's see kung makapag-create tayo. Okay na siya. Ayan. So the assessment has been activated. So yung mga hindi makakapag-exam ngayong oras na to kasi mabibitin pa kayo sa oras, pwede nyo i-take yung NetAcad exam ng 2 o'clock mamaya hanggang 11:30 ng gabi. Okay? Now, pagdating naman dito sa deliverables for this week, yung activity, so ito naman yung activity nyo. Kita ko lang sa inyo. Wait. So this is your activity. I'm gonna share this one and go to the modules. Let me see. Module 8. Isa lang naman to activity nyo. Yan, activity 8.1, network layer. So, pabaguhin ko lang dito yung date. Okay. Ang activity 8.1 nyo, simple lang. Ipakita nyo sa akin ang screenshot ng Ethernet concept exam nyo. Okay? O, ayan ha. Ang dali-dali nito ha. Ethernet concept exam. Okay? So, ibig sabihin kung ano ang score nyo doon, yun ang magiging score nyo dito sa activity na to. Okay? Malinaw po ba? So, ang deadline nito, dahil hanggang mamaya lang yung exam, okay, hanggang mamaya lang din yung deadline nito. Tama ba ako? Alam nga namang ang deadline nito bukas pa. Tapos na kayo mag-exam noon. Okay? So, mamaya, pwede nyo nang gawin to at i-submit nyo mamaya. Pagka-submit nyo ng exam nyo, i-submit nyo na rin yung screenshot ng score ninyo. Okay? Alam nyo naman siguro mag-screenshot, di ba? Dapat evident doon yung name ng exam, which is Module 4 to 7 Ethernet Concept Exam. And then, dapat evident din yung score. Di ba? Kasi yun yung magiging score nyo. Any question po? Any question? Malinaw yan ha? Baka mamaya may magtatanong na naman sa akin. Kasi hindi nakapokus ngayon, kaya later siya magtatanong pagka ginagawa niya na. Medyo nako-confuse. sana kung nakapokus kayo ngayon, hindi na tayo magkakaroon pa kasi malinaw naman ang instructions, di ba? Sa lahat ng ayaw ko yung malabong instruction. Kaya as much as possible, kapag nagbibigay ako ng instruction, dapat nakikinig kayo kasi malinaw naman lahat ang instruction natin. Okay? Any other question po before we end our meeting?